Hi guys, Max NG7M back for another quick video here. And quick is very relative to the videos I've made in the past, so we'll try to keep this one short and sweet. As you can see on the screen, I've labeled this video part 8.5. And so this is a follow-up to my part 8 video, which was very crucial because I go into the calibration of a B26-RF2K amplifier when you're driving it with power. So it's critical with this type of gear to get this right. And so there was a good post by a couple guys in the forum that watched my videos, and thanks for watching the videos and you know, making sure you know what I'm talking about there is correct. If I need to correct anything, that type of thing, I'll either do it in the notes. Sometimes it's hard to remake the video, and I'm not big into the video editing, so you know, going back editing the video, yeah, it depends on how big the problem is, I guess. And part number 8, I believe, is still very relevant. So again, this is talking about an amplifier put out by Reinhardt DH3 NAB, and you can watch the previous videos. Go to my YouTube channel. You can see the other videos there. This video is being posted to address a concern that guys that have taken shipment prior to early August, they were able to drive the amplifier on the low bands, 160 meters for example, to legal US limit power of like 1.5 kilowatts with about 15 to 20 watts of drive based upon how warm the LD MOS devices are, okay? But with my amplifier, from the get-go, once I started playing around with it, actually driving it with power, I noticed on the lower bands that I needed 70 watts of drive to reach legal limit output. And you know, all my gear and everything is, you know, pretty close for ham stuff. And so I assumed that there had been a change in the amplifier, and I had corresponded with Reinhardt, and he did talk to me about there being a change. And so I ran with it. I left the amplifier as delivered, expecting that to be the new norm. And so come to find out, after spending some more time talking to Reinhardt, he had a lot of guys complaining that the drive on the low bands was too sensitive. They wanted to be able to drive the amplifier as delivered with higher wattage on the low bands because their exciters or the transceiver that they're driving the amp with didn't have a granular enough wattage output. So there, you know, a lot of amplifiers only go down to 5 watts or 1 watt increments or whatever. I'm driving it with a L-Craft amplifier, and so up to 12, 13 watts, I can do tenths of a watt. So I don't have that issue. And so I would have been thrilled if I could drive the amp on 160 meters and 80 meters to full legal output with 15 or 20 watts. But that wasn't the case, right? So the manuals have been in flux, and so as I made step 8, I ran with the way my amplifier was shipped, and I'm sure there's several other guys that have the same amplifier. So this video and my long-winded explanation here will talk about how to revert your amplifier back to not requiring higher levels of input to drive full legal 1.5 kW, in the US anyway, out on the low bands. So here we go. Get me out of the way as usual, and we'll come down here. I'll also give a demo too and show you the power output with the amplifier cool. You'll see how little drive it takes to get 1.5 kW out. It's really amazing. Let's see here. Let's pull up some pictures, and there'll be a link, as always, in the description of the video. You can find these pictures. So I have a section on my photo gallery called Less Drive on Low Bands, Resistor Removed. So let's talk about this a little bit. This is a shot right here you can see on screen of the front of the RF pallet, looking down on the front of the RF pallet, where you can see your input from your exciter. The actual coax comes around, and the input goes through an attenuator pad, which mine is a typical 13 dB attenuator. So with 30 watts drive on one side, you want to only excite those LD MOS devices with 1.5 watts. So 30 watts in, 160 meters approximately, you're going to get 1.5 watts out here. Well, based upon complaints and gripes from guys not having granular enough control on the low bands, he added right here, see this 26R1, this is a SMD resistor, and I've actually removed it here and I just set it back on top of the other resistor here. But what you see right here is a capacitor and this resistor. These two components right here make up a very simple high-pass filter that as the resistance goes down here, so originally Reinhardt was shipping with a 100 ohm resistor. By adding this 26 ohm resistor in parallel, that dropped the resistance down on the little high-pass filter network, these two components in fact. Actually, this is an inductor, that's a capacitor there. This is an inductor. The capacitor's in the mix here too, I believe. So by adding in parallel a 26 ohm resistor, it dropped the resistance here for the high-pass filter down to, I think it's like 64, 65 ohms, which lowers the filtering frequency to where you're passing more of the input power, right, through onto the amplifier stage, on effectively to the LD MOS devices. So the 26 ohms right here lowers the resistance. It requires higher drive on the lower frequencies, and that gave guys what they wanted. So the documentation does not cover this. And so there's been some confusion around image 055. There was a new calibration manual for that. There was a supplement put out. There was another really good edition that combined the two calibration manuals, and that's what I used on the first 7 videos. So the first 7 videos are applicable regardless if you have an amp that ships with this resistor in parallel right there, that 26R1, or if you don't have that resistor. The difference comes into play with step number 8 video. So I adjusted step number 8, the video, as though you have this resistor installed here on top of the 100 ohm resistor. So here I'll show you a picture as I removed this resistor to show the typical input power required to drive full legal limit output in the US on 160 and 180, like guys previous to the August shipments have. So hopefully this clarifies that. So here you can see I've lifted the resistor right here, and I've actually already resoldered underneath it here. I just show this, right? So you're gonna have to rework this, use some solder wick, pull off the resistor only if you want lower required drive on the low bands. You can leave this on, right? If you, depending on your exciter, you may want to leave it how it was before, but it makes the calibration in the first 7 videos a little confusing, because in there it's very clear that you calibrate input protection based upon the 160 meter band at 1.9 megahertz. And so, once you calibrate 160 meters to go into protected state, kick out of operate into standby in a protected air mode at 30 watts, there's no way you're going to get 1.5 kW out on 160 meters. And so I understood that this was a permanent change, and maybe it still is a permanent change on the RF Pallet or the RF decks that are being shipped by Reinhardt. And so I made step number 8 video to go along those lines, and so I calibrated my protection level at 70 watts for 160 meters because that was the band that required the most drive. Well, as I describe in video 8, if you actually have the attention span to watch my whole video, step number 8, some guys don't have that attention span. I've come to find that out very clearly. I made that clear. You actually have the ability to then overdrive the other bands because the drive protection is much higher than the other bands you'd ever want to drive them. And that's just the way it is. That's the give and take with what Reinhardt did to satisfy the guys wanting more drive requirements on the lower bands. And I keep repeating myself. So let's get back here. So I removed the SMD resistor. So 26R1 is out. Put it aside. If you want to put it back, you just have to solder it back on top of the 100 ohm resistor. And so now my amplifier that I'll demo right now is set up with the 100 ohm resistor. And so this is an SMD resistor, and so the notation on here is 10 times 10 to the power of the ohms, and in this case, so anyway, it has 1,000 on it because of the SMD notation, which is 10 to the 10th power of 0. So 10 times 10, 100 ohms. So it's still a 100 ohm resistor there. And you can see I didn't do a great job lifting off the other resistor. I have a little skid mark right here with my soldering iron that I'm not very proud of. I take my soldering skills pretty seriously. So anyway, resistor is removed. So this little filter network here is now allowing a lot more power through and not, you know, attenuating that power post the attenuator input. So NG7M's amplifier now should be very similar to what other guys were reporting across the bands. And there's some very good posts on the forum where guys have taken notes and been good enough to share what kind of output they're getting. And everybody's going to get a little different. And plus the, as I've described over and over, the SWR, the forward power, reflected power meters, are, you know, they're all going to be within, you know, 100 watts either direction, and it's still considered pretty accurate. So all right, let's get rid of this and let's pull up VNC. So as you can see, I'm on 160 meters here, and I'm going to go out of operate there. I'll pull up my little virtual meter here so we can see. Oh, and I did find out if you're using tight VNC, a little digression here, you can actually make this like ginormous here, really big, like big. So you can just double the size of the screen or whatever you want. So I can make that big or smaller. So we'll make it big. All right. And we'll leave me pretty small here. So what I'm going to do is I'm going to go up through the bands, and we'll call this video good. Now that you know about the resistor, you understand that my step 8 video is or was created based upon 70 watts drive required on 160 meters to get full power output. Well, now it is far less. It's amazing how in that little filter network that Reinhardt designed, you increase the resistance there in that filter, and this is the difference it makes on the low bands, right? Because you're allowing that input to go through. So here, just to show you the drive level I've got right now, I'm in standby. I've got cat control on. We're at 1.9 megahertz, and I'm just going to go through the bands and get this video posted. So here I'm about 18 watts drive. The amp is cooler. Let me drop it down maybe to, you know, we're at around 15 watts. We're going to go to operate, and I've got peak hold on here. And peak hold's going to show a little less than if I were to tune the amp, but you'll get the idea. So here, around 15 watts drive, the amp is at 37 degrees centigrade. We're going to loop back around to 160 meters when I'm done, because when the amplifier is warmed up, and I use an amplifier, I am a CW operator, I'm an RTTY operator, I rarely operate sideband. If you're only operating sideband, this amplifier is going to be loafing along in slippers, right? I mean, if you're going to use the amplifier and drive it hard, you're going to be operating CW and RTTY, and even FT8 if you're, you know, pumping out a kilowatt on FT8. Wow, that's a whole other discussion, right? FT8's a low signal mode, but not a low power mode. Another discussion. So as the amplifier heats up, you're going to see a lot different output, and you're going to require more drive, even 160, you know, even up to 30 watts potentially. So I'm in operate, 160 meters. There you go. Back to standby. That's 17 watts, 18 watts out there, as compared to 70 watts before, simply by lifting that 26 ohm resistor, increasing the resistance there to 100 ohms. So we're going to go up to the next band. So here we're on 80 meters current input. Looks like it's around 15, 16 watts. I'm going to go into operate. There you go, over 1500 watts. Going to go to the next band. We're on 60 meters. Looks like I've got 22 watts drive there. And it's going to require a little more drive, especially as you get above 20 meters or 14 megahertz. So here's 60 meters in operate. Yeah, so there, man, we're pumping out. So I dropped the drive there a little bit. Still around 20, 21 watts, give or take a few watts. Okay, next band. 40 meters. And I'm in standby. And again, up there, I'll drop it down a little bit there. Let's see what we get here. The amplifier deck is at 39C. The fans haven't even come on yet. And there's legal limit. Okay. Standby. 10 megahertz. You can tell I had the amp pretty warm when I had my drive level set. Turning it down because it's pretty cool. Okay, there. Okay, there's 25 watts or so on 10 megahertz. And 24 watts. Next band. 20 meters, the workhorse band. I currently have the drive at 13 watts or so. Well, that's on the K3. My LP700 is saying about 13 watts, I guess. Let's see what we get here. Okay, so there's 13 watts there. Not quite 1.5 kW. Turn it up a little bit. There, up to 1600 watts there. And that was with less than 20 watts. Next band. 18 megahertz. The fan just kicked on. You won't hear it. It's so quiet. I even have it on the higher voltage. So let's see what we get with 11, 12 watts here on 18 megahertz. Okay, close to legal limit. Okay, that was with around 20 watts drive. Next band, 15 meters, 21 megahertz. Okay, 15 watts or so. Operate. Okay, so there is with 20 watts. Now let me show you just in tune mode, because you're getting a little bit of an average there because I'm sending a bunch of V's there on the CW key. I guess I could turn the monitor up a little bit so you can hear me with that. So here I'm going to drive the power up to 1500 watts out, and this will warm it up a little bit too. Oh, if I put it in operate, that is. Doesn't stand by. Okay, here we go. All right. So here, I'm going to drive it right up to 1.5 kW out. Okay, right there. I'm going to unkey. You can see the temperatures at 45C, and as the deck heats up, right, the output's going to go down. So we're warming it up a little bit, and I still doubt you'll be able to see or hear the fans rather. Okay, so now I'm going to unkey here on 15 meters. Go to standby. Let's see what. So right around 22 watts there, and the deck's at 53 degrees centigrade. Okay, next band. 24.9 megahertz. Let's see what. Okay, about 15 watts there. Operate. Okay, let me drive it up a little. There you go, legal limit. About 24 watts. The drive power is going to increase as we go higher. It's not as efficient. So 10 meters, 28 megahertz obviously. I've got the drive currently at around 35 watts. Well, let's see what the... Yeah, right around 35. So out of standby, operate. So 35 watts drive, 36. So we're hitting legal limit there on 10 meters. Great. Fantastic. Okay, next band. 6 meters. I'm only going to drive it to 600 watts here, and this will require higher drive. Now I have noticed that the previous guys that showed some charts, they weren't taking quite as much drive on 6 meters to hit 600 watts. So I can only guess that there might be some differences in our meters, or there's been some minor changes to the RF deck. I don't know. If you've had your amplifier for X amount of months, right? Reinhardt's continually improving it. And so I don't know if you have the exact same amplifier. So again, these videos are a reference as of amplifier shipping early August if you have that resistor in place. Or now you can remove it. You know, take your pick. You can remove the resistor, and hopefully this will make a lot more sense now. Okay, so I'm in standby on 6 meters here. I've got it around 40 watts drive here. We'll drive it up to 40 watts. Okay. And then it's normal to see a little higher SWR on the higher frequencies, even in a good dummy lug. So let's go to operate here. Okay, so let's just send a bunch of DAWs there. I'm going to drive it up to 600 watts, and then we'll see what we'll go to standby. There's a good 600 watts, right? And you can see the amperage draw here is less, right? 32 amps. You're going to see a lot more amperage draw on those lower bands. Well, of course, we're only driving it to the 600 watts. You know, that's just the efficiency of the current transformer on the RF Pallet too. So the driving it to that was 63 watts. Okay, so let's circle back to 160 meters. I'm gonna warm it up a little bit here. We're gonna go into operate, and so right now we're at 45 C. I'm gonna warm it up a little bit here. I'm gonna sit here a second. I'm gonna drive it up to a kilowatt here. And so here at a kilowatt, we're drawing about 38.5 amps, and you're going to see the power output go down. So if you're in the heat of the battle in an RTTY contest or CW contest and you're driving it hard, and you've got the heat up, you know, to 55 C or 60 C, you're going to require more drive than 15 watts, even on the low bands. So now we're at 53 C. I'm going to unkey it there, not get too crazy. So now I'm, just to show you the difference, so we're at 16 watts. Let's see what we get out here now. Still pretty darn good, right? If I drive it up to full legal limit out, back on 160 meters, even with the RF deck pretty warm, and I'm not paying attention to the meter on the amplifier, I'm basing all this on the LP700. So stop it, go back to standby. Okay, so it was requiring 30 watts right after the deck heats up. You're going to require more power. When it's cold, everybody loves to say, oh, it's only 15 watts drive. Well, heat the amplifier up, and it's going to take some more drive. It's just the nature of the game. So, video 8.5 is done. If you have any questions, get on the forum, make objective comments. If you disagree with what I have to say, please send me an email direct to make sure we're on the same page. I'm doing this just for fun. I don't get anything out of it. I don't get a free amplifier or anything. I just think it's an awesome project. You know, for one guy to take on this type of a project is really amazing. Um, very cool. The price is right. The amplifier has great potential. Have fun, get on the air, learn a new mode, operate, make some cues, and have fun. That's the main thing. Go and use your amplifier after it's set up. 73 for now, and good luck with your B26-RF2K Plus and G7M 73.